For millennia, humanity has gazed upon the night sky with wonder. The vast expanse above has always been a source of fascination and curiosity. From ancient civilizations to modern astronomers, the night sky has been a canvas of dreams and mysteries. The stars, like celestial diamonds scattered across a velvet canvas, have inspired countless myths and legends. They have been guides for travelers, symbols in our stories and markers of time. Each star, a distant sun, holds secrets of the universe. Yet, one of the most enduring mysteries lies closer to home: the origin of our own solar system. How did the sun, our life-giving star, and its family of planets, moons, and asteroids come into existence? This question has puzzled scientists for generations. How did this intricate dance of planets, moons, and asteroids come to be? What forces shaped their paths and determined their fates? The answers lie in the distant past, in the very fabric of the cosmos. Our cosmic journey begins billions of years ago, long before our Earth existed, in a time when the universe was still young and the building blocks of our solar system were just beginning to form. Imagine a vast cloud of gas and dust, a nebula adrift in the cosmos. This nebula, rich in elements, was the cradle of our solar system. It was a place of immense potential, where the seeds of planets and stars were sown. This nebula, the birthplace of our sun and all its planets, was a chaotic and turbulent place. Within its swirling clouds, gravity began to weave its magic, pulling particles together, creating clumps that would eventually become planets. But within this swirling chaos, the seeds of order were sown. Over millions of years, these clumps grew, collided, and merged, forming the early building blocks of our solar system. It was a time of great upheaval and transformation, setting the stage for the birth of our sun and its planetary family. Gravity, the architect of the universe, began to draw the particles of the nebula together. As the cloud contracted, it began to spin faster and faster, much like a spinning figure skater pulling their arms inwards. This swirling motion flattened the nebula into a disk, with most of the mass concentrating at its center. This central region, under immense pressure and heat, became the crucible for the birth of a star. The relentless crush of gravity continued to pull in more and more material, heating the core of the collapsing nebula to unimaginable temperatures. At the heart of the disk, the temperature and pressure reached a critical point. Hydrogen atoms, forced together under unimaginable force, began to fuse, releasing a tremendous amount of energy. This event, the ignition of nuclear fusion, marked the birth of our sun. With the sun blazing at the center, the remaining gas and dust in the disk began to cool and coalesce. This marked the beginning of planet formation, a process driven by gravity and shaped by the interplay of temperature and density across the protoplanetary disk. From dust to planets, the accretion process. As the disk cooled, microscopic dust grains, remnants of the original nebula, began to clump together. This process, known as accretion, started small, with dust grains sticking together electrostatically. As these clumps grew larger, their gravitational pull increased, attracting more and more material. Over millions of years, these growing clumps became planetesimals, the building blocks of planets. These planetesimals, ranging in size from meters to kilometers, orbited the young sun in a chaotic dance, colliding and merging, gradually forming larger and larger bodies. Gravity's shaping hand. Gravity played a crucial role in shaping the solar system. The sun's powerful gravity kept the planets in orbit, dictating their paths around the central star. But gravity also influenced the planets themselves, pulling them into spherical shapes as they grew larger. The gravitational interactions between the planets also played a role in shaping the solar system's architecture. The giant planets, Jupiter and Saturn, with their immense gravity, influenced the orbits of smaller bodies, sculpting the asteroid belt and the Kuiper belt, regions populated by remnants of the early solar system. Planets of fire and ice temperatures roll. The universe is a vast and varied place, with temperatures ranging from the blistering heat of volcanic landscapes to the frigid cold of icy terrains. These extreme conditions are not just fascinating. They play a pivotal role in shaping the very nature of planets. The temperature gradient across the protoplanetary disk played a crucial role in determining the composition of the planets. In the early solar system, this disk of gas and dust was the birthplace of planets. The varying temperatures within this disk dictated where different materials could condense and accumulate. Close to the sun, where temperatures were scorching, only rocky materials with high melting points could condense. These materials, such as metals and silicates, could withstand the intense heat and began to coalesce into solid bodies. This led to the formation of the inner rocky planets, Mercury, Venus, Earth, and Mars. These planets are characterized by their dense metallic cores and rocky surfaces, a direct result of the high-temperature environment in which they formed. Further out, beyond the frost line, temperatures were cold enough for volatile compounds like water and methane to freeze. This region, far from the sun's heat, allowed ices to form and accumulate, providing the building blocks for a different type of planet. This allowed the giant planets, Jupiter, Saturn, Uranus, and Neptune, to accrete vast amounts of gas and ice, becoming the gas giants we see today. These planets, with their thick atmospheres and extensive ring systems, are a testament to the diverse conditions present in our solar system's formative years. A system takes shape, moons, asteroids, and more. These celestial bodies, each with their own unique characteristics, play a crucial role in the dynamic environment of our solar system. As the planets continued to grow, they also began to acquire their own retinues of smaller bodies. These smaller bodies, including moons and asteroids, were captured by the gravitational forces of the planets, adding to the complexity and diversity of the solar system. Moons, formed from the disks of material orbiting young planets, became trapped by their gravitational pull. These natural satellites vary greatly in size, composition, and appearance, with some being geologically active and others remaining dormant for billions of years. Asteroids, remnants of the early solar system that never coalesced into planets, scattered throughout the inner solar system. These rocky bodies, ranging from tiny pebbles to massive boulders, provide valuable clues about the conditions and processes that shaped our solar system's formation. The Kuiper Belt, beyond Neptune, and the Oort cloud, even further out, became repositories for icy bodies, remnants of the early solar system's outer reaches. These distant regions are home to countless icy objects, some of which are occasionally disturbed and sent hurtling towards the inner solar system. These icy bodies, occasionally nudged by gravitational interactions, can become comets, streaking across the inner solar system, leaving trails of ice and dust in their wake. Comets, with their spectacular tails, have fascinated humans for centuries, serving as both scientific curiosities and cultural symbols. Please like and subscribe to FactFusion for more cosmic stories.